So we are going to discuss paper 9702. Paper 22, February March 2022. The total time for this paper is 1 hour and 15 minutes, and it's better to go through the instruction. And then after that we are going towards question number 1. So keep it in mind, in new syllabus the data booklet is here, all the constant values and equations, some equations, new equations are in this one, so please must go through these ones. For question number 1, question said a sphere of radius r. Whenever you have any important thing in that, it's better to underline that one. 2.1 millimeter falls with terminal velocity through a liquid as shown in figure 1.1. Three forces acts on the moving sphere. The weight of the sphere is 7.2 10 to the negative 4 Newton, and the upthrust force acting on it is 4.8 10 power negative 4 Newton. The viscous force Fv is acting on the sphere is given by, so this is our viscous force, that equal K time radius time V, where K is the constant and the value of this K is given to us, that one is 17. They said to determine the SI base unit of K. So we are going to find the unit of K. From viscous force, we know that the K equal viscous force over radius time velocity. First force is the unit is the kilogram meter per second square. Then you need to write the unit of radius, that is meter, and the unit of velocity is meter per second. After plugging these values in this equation, we will get kilogram per meter per second. Very simple. Now the second part is use the value of the upthrust acting on the sphere to calculate the density rho of the liquid. Now we are going to find the density of the liquid in this part. And if you can see that this formula is given to us in our formula page, that one is F equal rho G into V. So this is in our formula page, where rho is the density, G is the gravitational field strength, and V is the volume. As we know that the upthrust force is given to us, so upthrust force is 4.8 10 to the negative 4, and we are going to find the density while the G value, and make sure you are plugging here 9.81 not 10. 4 over 3 pi into r cube, need to convert this into meter, from millimeter to millimeter, and then the density of the liquid is 1261. Please make sure that for this one you are going to write two significant, so it's better to write 1300 kilogram per meter cube for this one. Next, then they said on the sphere in figure 1.1, draw the three arrows to show the direction of the weight W, upthrust U, and the viscous force Fv, and label these forces with weight W, upthrust U, and viscous force V. I'm going back to the diagram. Very easier one. If you can see, the two forces are acting upward. One is the upthrust, the second one is the viscous force, and the weight is acting down. And please make sure that your arrows should be in such a way that they are going to balance your downward weight. So I am just adding here, this is my first mistake, this arrow you can make bigger, and this viscous upthrust you can make smaller here compared to this one. So sum of these two arrows should be equal to this one here. So then, because this object is moving with the constant velocity, so we need to be very careful about that one. The arrow's length should be up and down should be same. Next one, the last part they said here, determine the magnitude of the terminal velocity of the sphere. We are going to find the terminal velocity in this part. And we know that the terminal velocity, when we are going to find, we have the three forces, as if I can show you on diagram. Upthrust, this is your viscous force, and this is our weight, Fv, U, and W. As the object is moving with the constant velocity, so it's mean the resultant force is zero, and the sum of downward force equals, here we have only one sum of the downward force equal the sum of upward forces, so that equal Fv. And you know that the upthrust force we have already given to us 4.8 10 to the negative 4, while the weight is also given to us in this question 7.2 10 power negative 4. And we know that F is the viscous force is K time R into V, and we can find this V is our terminal velocity. After simplifying this one, we have the radius, we have the K value is 17 given to us above, so we can get the velocity value is 6.7 10 power negative 3 meter per second.